Good evening.
A very good evening to all the participants and our speaker for today's session. This is the second today's speaker infrastructure solution, advanced material for civil engineering. So on a short, just I want to say, introduce again our speaker, Sir Lakshmivara Prasadem, now working as Associate Professor in the Department of Civil Engineering, National Institute of Technology, Silchar. And the area of research of SAR is performance of structural elements under static and dynamic loading, new age materials, in concrete waste management, in construing quality control and quality assurance of construction, artificial intelligence in construction management. Also new construction methods and equipments. SAR has guided 4 PhD scholars, 38 MTech scholars, and 25 BTech scholars. And presently, the ongoing candidates, PhD 5 numbers, MTech 2 numbers, and BTech 1 number. SAR has served in NIT Silchar in different positions as faculty advisor for karate and skating, faculty advisor for Eco Club, member of examination branch from Civil Engineering Department NIT Silchar, faculty advisor for Photography Club, associate dean P&D NIT Silchar, FIC operation and maintenance of Central Library NIT Silchar, associate dean student welfare NIT Silchar, and he has memberships in different prestigious governing bodies, like he's member of Indian Concrete Institute ICI and executive member secretary ICI Guwahati Center, member of Institute of Engineers India, and member of Indian Society for Technical Education. So now I request all the participants, when our speaker is delivering, kindly mute your phone so that the presentation can be presented in a proper manner. Now I request Sir Dr. Lakshmi Baraprasadem to address our participants in the topic 3D concrete printing application and future prospects. Sir.
Thank you, sir. Thank you, Dr. Pankaj Kumar Das, sir.
Thank you, sir.
for giving an opportunity. And once again, I am saying thanks to the patron, Sri Binod Das of this FDP, and Mosami Mohapatra Madam for arranging these necessary things and all that. Thank you, sir. So now I will share my PPT, sir.
Sir.
Sir, is it is shared, sir? You are able
Sir?
to see PPT is
Yes,
able.
yes, sir. It is clearly visible, sir.
So slides are changing now, sir. Slides are changing.
No, sir. First
Oh,
slide is there.
first slide is there, na? Okay. Then just once again, I will share that one, sir. So some problem, I think. Now,
Yes, sir.
sir.
Yes, sir. Now it is changing.
Now it's changing, na? Thank you. Thank you, sir.
Okay, sir.
So,
Okay, sir.
dear participants, thank you for joining this session. So today we are going to discuss about the latest technology in our civil engineering field, which can give you the future prospects and so many different applications, because with the 3D printing, you are going to save the time, you are going to have the latest techniques, and you are going to have the different world of printing, actually, concrete printing. Whatever the limitations are there in our regular, because we are going to have some, even in case of three-dimensional, if you want to go for a concrete, generally it is not possible with the different shapes. Only with a regular shape only we can do, but if you want to do in different shapes, it is not possible for the regular concrete. But here we will go, we will see and how to prepare the different modes of concreting, different shapes of concreting. So our topic today is 3D concrete printing applications and future prospect. So today I am going to cover basically what is 3D concrete printing, then what are the benefits of 3D concrete printing, then how this technology developed in the first, we will try to develop only modular laboratory model instead of going for a high-end practical field application. Just if you are able to understand that in the practical, in the laboratory, just with a small model development, then we can adapt it in the larger scale in the field also. And what are the additives can be used for 3D concrete printing? Mainly problem comes with the additives only. Actually, what happens is when you are going for the 3D printing, the material cost is going to be very high if you are purchasing the additive from outside, actually. So if you are able to make indigenously at your lab, or you are able to develop that required material, you are able to develop that at your own end, then the cost of 3D printing is going to be very less. And even the technology, whatever it is there for 3D printing, preparing this arm, then going for this robotics, then internally whatever this software is going to be there, and how to write this coding, all these things, if you are, it is very simple, it is not a difficult thing. Those who knows about writing a code, because earlier days, if those who have an idea, when you are using the stat 3, at that time we are not going to have any Stat Pro like selection toolbox. You have to write the code itself. So similarly, if you are able to write the code here by using any own language, yes, uh, no problem, na? So we can prepare the additive, and what are the challenges and limitations. However, it is going to be a new technology, but you are going to have some challenges here, and definitely some limitations will be there. For every upgradation, for every research, you are going to have some limitations on that work. So what are that limitations? Then what are the future prospects of it? That we are going to see today. So basically, when you say 3D concrete printing means, you see here, I have shown the two pictures here where layer by layer concrete printing is going on. So basically here, main thing is arm preparation. That is, you can see here how it is prepared. This once you give the command, automatically it will going to finish your model. And here also you see complex shapes actually here. Even if it is not a regular shape also, but layer by layer it will give. Yeah, actually, we are giving a double layer here. One straight layer and another layer is a curved one. So like that, this is called a notch, and this arrangement will be there. From here only that additive is going to come. But when you are preparing the additive, you have to take care that because it to even with respect to its self weight also it should withstand the shear, and with it, it should withstand after giving a layer within a 5 minutes we are going to give one more layer. So by that there should be a proper between the layers, and there should not be any bending, or there should not be any problem with the own weight. That also we have to consider. So for that, actually this whatever the concrete we are going to prepare, it is going to be very not by using very big size of aggregates, very small size of aggregates only we will use in the preparation, and we will prepare it. So basically here we will do layer by layer, and mainly innovative method, what we can say here, combines the advanced robotics, material science, and digital design. Because what we will do is actually this is just like those who have an idea about the artificial intelligence. What we will do in the artificial intelligence, first we will take the whatever the input it is there, that we will give input, and we will train it for the result. Then we will expect the output. So similarly here as a input, we will give the this robotics. Initially chips are going to be there, and otherwise through a computer command, there will be a monitor to give the commands. So from that monitor, we will predefined coding is going to be there. Suppose let us say you have a plan. Suppose if you see here, it is just like a model it is preparing. So first, this shape of plan, we will draw it using AutoCAD, and we will transfer it to this, and we will share this plan to this, and with how much thickness of walls we have to maintain, that also we will mention in the coding. And from that, once you give the command, so from this robotic arm, it will start printing first layer, then it will come to the end, then it will start the second layer. Like that, layer by layer, whatever the plan you have given, it will complete finally. So the application wise, if you come, it may be residential buildings, or it may be very big infrastructure projects, or disaster relief areas, or in anywhere now this technology is going to be used. And what are the benefits of 3D concrete printing? See, in earlier days, or without using this concrete printing, I cannot prepare just by using our regular concrete. Here, see, conical shape, one model it is prepared here, starting with lesser dia to higher dia, or higher dia to lesser dia. Here you can see here. So these type of variety shapes of the structures, basically you cannot do with our regular concrete, and with the smaller thickness of this one, particularly for preparing the models, or even with the concrete only, this by using this concrete only you can prepare. See, you can see here, this is a pedestrian bridge which is prepared by concrete printing. Simply, these are the layers actually. So they prepared and they attached here. Prefabricated one by one, they taken and they are attached in the middle. It is hollow portion actually. From that, they by using the pre-tensioning or post-tensioning concept, these slices are attached to make the pedestrian bridge, a small bridge. Similarly, if you see, this is a panel actually. It may be a roof panel or it may be a wall panel like that. You can use this panel. So at different shapes with the here a column like support I have given. Then here hollow partition walls. Even I can prepare because this side I have given one layer. That side I have given one layer, and in between hollow I am doing. So by doing this, even you can develop the green concrete technology, and you can control the thermal resistivity and all these things. So that is the advantage of. Obviously, when you come to the efficiency, there is a increased efficiency actually. If you say in efficiency wise, there will be a increased because there is a reduced construction time. It is not manual, it is directly from the machine. So once you give the command, and automatically it will follow the command and it will finish. So labor involvement is very less, no need of more labor in this case. So that also one of the advantage. And sustainability. See, when you are going to prepare this additive, particularly you by using environmental friendly materials and reducing material waste and lower energy consumption, these are the main sustainability aspects we can follow here. Design flexibility. Already I told you, any shape, I will show you some more figures also. Even nowadays, whatever the idols you are going to see, or in some puja time also, now they are printing with respect to this 3D printing technology only. Uh, that is the flexibility. Even you can go for a different shapes and structures. That is the flexibility. Cost effectiveness. Obviously, when you are able to develop the required additive at your own laboratory or at your own site, there is a reduced cost, and there is a saving. Excuse me. So even with the concrete printing, if you see here, if you are preparing a ready mixed concrete also, if you are preparing the ready mixed concrete also, from that also how it is connected, concrete is pumping to the required motion for the printer, and from that we are going to have the layers actually. Okay. So, and if you see the cementitious materials or geopolymers, basically here I am going to discuss, even you can prepare with the regular cement also, but instead of that, if you go with a geopolymer, because the advantage of geopolymer concrete is here you are using sodium silicate and sodium hydroxide solution with the binder, so that that is prepared and it can be used, and in that paste or in that mortar, oh, very light amount of aggregate, only up to a 6 mm only we are going to add in this, and that is we are going to as a additive, and it is very much useful in the preparation of these layers. And you can see here model, if you see this model, a different model. These are prefabricated, and particularly these type of models, you can use them as a disaster responses and disaster recovery things also. You can use it, and even commercial and public facilities, if you see, this can be provided in as a commercial or public facility. Suppose you want to prepare some on a drainage, you want to give the cover of it, and it should be a footpath like thing. Then you prepare the layers from this and you put there one by one, then they will cover the drainage system like that. And even you can develop the residential buildings also, and infrastructure projects. Even in big infrastructure projects, here I am mentioning a 29-meter long 3D printed concrete bicycle bridge is prepared, because actually till now research is going on. We cannot go for a heavy loads simply. Pedestrian bridges or bicycle bridges like that only we are going till now, but in future it will be applicable in any area. Okay, but when you come to the concrete printing technology, from technology wise, if you say, we have to design the we will design by creating a digital model of the structure using CAD or BM software. Basically, what we have to do, first you have to give the your required plan to it, whatever may be your plan. So you have to give it, you have to create that plan by using your CAD or BAM software, building information modeling software. So from that you have to give the model and it will take that design, and accordingly that slices are prepared, dividing the model into printable layers. It will divide the given model into printable layers, then extruding a specially formulated concrete mixture through a nozzle, building the structure layer by layer. So you can see the nozzle here. Here, this is the nozzle and this is the mixer plus extruder. From the extruder only, it will reach up to the nozzle, and the robotic arm is going to be there. And this robotic technology, actually for developing this robotics and all that, generally we will you take the help of our even your E&I and software, computer science friends are there. You take their help within your college only. No need to go for purchase. Actually, nowadays, these 3D printing machines are available. I have one is there in Delhi and one it is there in Hyderabad. They are also providing ready-made, but they are charging. Yes, their charge is also very less, but some outside companies also providing directly. Suppose you are not having that much of technology in your lab to develop on your own, then you can go for purchasing it. It is costing around 30 lakhs to 40 lakhs like that. Simple laboratory based also. Instead of that, if you indigenously, if you develop na, you will get, because you have to maintain this, you will. Whatever the material you are using, everything you develop on your own, then it is going to be very economical actually. So that's why take the help of your friends, which those who are working in different branches of your department. Here we are doing like that only actually. We are taking the help of electronics and instrument people for this chips and all that, how this robotic arm is going to work. And for the software part, this we are going to take from the help of the computer science people. So they are going to help us in developing this technology, and we are in the trials. Even if you are not able to go for developing a automated mode, this is what our saying is, it is automated. If you give the command there, instead of that, suppose if you want to do manually a layer, you take a hopper type shape, and from that you arrange the nozzle from your end. The nozzle opening, you can fix your size like 3 mm, 4 mm, 5 mm like that, or 6 mm, whatever the size of the thickness of the layer you want. Then you go for, just you take some strips, and in that strip you try to go for layer by layer, because when you are developing this technology, you have to see at what consistency the cement mortar is going to be withstanding, because whatever it is there is, first I am going to give the first layer, then after that, after some time, I am going to give the second layer, so that it should withstand the weight of the second layer, and it should, by that time, it should be in the sufficient hardened state, so that it is not going to disturb the, suppose if it is not able to take the load, whatever it is cupping on it, then it is going to collapse actually. And then there may be a shear failure, or there may be a punching failure. So we have to see all that, at what ratio we have to prepare the mixture, so that after giving a one layer and after giving some time, so from the second layer, it should withstand its own weight, and along with that, the next layer, whatever it is coming on it should withstand, and there should be a proper bonding between these two also. Suppose if they behave individually separately, this layer is behaving separately, that layer is behaving separately, then this is not at all going to be useful actually. So because of that, actually we have the concept called layered concept, that we will say functionally graded concrete. Have you heard that? Functionally graded concrete is also going to be there in our civil. So from that also, you have to learn the some basic things about the functionally graded concrete. So you people are following now? Yes, sir. Is it visible only, na, sir?
Yes,
No
sir.
problem, na? From the.
Yes, sir, it is visible.
Uh, okay. So, in between, if anyone wants to discuss anything, anytime you can stop. Particularly, I am saying with the participants, because if you have any, if you want to discuss, or if you want to have any thing you want to uh, have any idea, I will give sufficient time to you people. So come out with your doubts, okay? Because it should be in two way actually. Only if I am saying, if you are not saying anything, then I don't know whether you are following or not. So that's why. If hello, if anyone is having any doubt related to that, you can stop me and you can ask any doubts. Okay. So curing. Actually, generally, you can, if you use a regular concrete, then you have to go for regular curing. Otherwise, if it is a geopolymer concrete with the combination of different additives of binder material, then there is no need of curing. Even ambient curing is sufficient. And finishing. So when you are going to finishing, adding windows, reinforcements, and utility post printing. So generally we will go for layer by layer. Then in between, if you want, you can put some reinforcement and all that. Even if you want to put in between windows, doors like that, then after also you can finish it actually. Okay. So now if you see here, I have given you here two yeah, buildings which are prepared in India by using this 3D printing technology. Is it visible? One is from IIT Madras and another one is post office which is prepared in Bangalore. So 3D concrete printing building, first building in India, it is developed in IIT Madras and in Bangalore. These two are the, if any time you get permission when you are visiting IIT or when you are visiting this Bangalore, all the civil engineers go and see how they have developed what, because they have mentioned all the things. I have visited IIT Madras and I have seen this building actually. So what is the, they have given one small details they have given there, how this, what are the materials they have used, by what technology they have used in developing this, then what will be the time it is taken, what is the area of this. Even you can see this here, they are not giving a simple rectangular, they have given a curved portion here. Here you can see this is a curved portion. Even if you see this portico also, it is not straight, somewhat inclined. So like that, all these latest things you can do only from the 3D printing only. In regular concrete, in regular, it is not that much easy to go for curved shapes or to go for any elevations like this. Okay. And customized home. Already I told you here, this customized home is prepared based on your complex geometries. And even you can see here, it is in the circular form actually. This post office, it is prepared like a circular shape and they have prepared. So that load bearing walls you can do by layer, But in between, let us say I came up to a 3 feet height or 4 feet height, then I have to stop. I have to give an opening for a window. Similarly, here also you can see here they have given an opening for a window. Then these prefabricated lintels will be there from the 3D printing only, and that they are going to put, again they are going to finish this like this. You can do. Even when you go for commercial buildings or affordable houses also, what we can do is after finishing the, here no concept of separate framed column, beam and all that. Simply it is going to be, generally till now we are using only G+2, G+1 like that only. Particularly in India, we are using G+1, G+2 only. We are not going more than that. But in future, if you go for the combinations, definitely we can use it in different commercial shapes and in different shapes also actually. Okay. Yeah. What is the long term durability of 1 minute? I will read it. Someone is asking, what is the long-term durability of 3D printed geopolymer concrete in an aggressive environment compared to conventionally cast geopolymer concrete? Okay. When you are comparing only with the geopolymer concrete, obviously regular geopolymer concrete is somewhat better. And because here in 3D printed geopolymer concrete, whatever the additive you are using, there we are going to use a maximum size of 6 mm to 10 mm only, and other things are same. Whatever the alkaline solution you are using, whatever the binder you are using, all other things are same. So because of that, in aggressive environment, when you say, obviously the actually it is when compared to the regular concrete, obviously it is very good because it is a very high durability characteristics because of the impermeability of the concrete, because it is prepared by from the geopolymerization. So because of that, you are going to have the very high impermeability, and the water binder ratio is very less. The usage of water is also accurately, we are going to use no more excess water is going to be there. So because of that, actually, what I can say is, I can say is, it is very durable actually. But when it comes to the compared with the regular geopolymer concrete only, actually till now we have not gone for the complete study of the comparing with the regular geopolymer concrete to the because I am also in preparing the up to the layered stages, and we have prepared only walls only. Actually, we are also not completed. Uh, Not visible means what? It is not visible. Slides are not visible. Hello? Now it is visible.
Sir, now visible. It is visible, sir. Now visible, sir.
Now visible. Now okay. Okay.
Visible,
Thank
sir.
you. Right. Right. Thank you. So. So actually it is in the trial only, but I can say durability wise and fire resistance wise, obviously everyone knows geopolymer concrete is very strong. Even it is going to give strength properties also very good. But when you are going for the aggressive environment means, can you say what type of environment? Aggressive means generally we are having different. Suppose if there is a acid attack, sulfate attack, or like that, or aggressive means it is a very hot area, or what type of aggressive environment? Can you say anything? Hello? Or exposure conditions are acha, resistance to freeze and thaw cycle, sulfate, chloride, ion penetration, carbonation. Okay, these are all durability problems. So freeze and thaw, here it is good because it is going to have very high thermal resistivity. either in either in I can say either it is in aggressive environment, means either it is in the uh, when it is freezing is there, when it is thawing is there. In both the cases, it is going to respond very nicely. And we are also studying in that area. In deep study, definitely we have to do. But till now, I have published and I have a patent on regular concrete only. But I am trying to get the all the things because I am in the trials only. So that's why I cannot say confidently whether this is going to be strong when compared to that. But obviously, it is going to give good results when compared to our regular concrete. Okay. And one more question, I think uh, they are asking here. Just wait. So resistance, sir, research scope related to 3D concrete painting. This is very good question, and there is a very high-end scope is there. I can say here you have a very high-end scope with respect to this 3D concrete painting, because nowadays everyone is saying review papers. If you see 3D concrete painting, so many papers are coming. But particularly if you are preparing the additive from your end, and if you are preparing the, even if you are able to develop that prototype model for laboratory purpose itself, because it is research oriented, na, definitely there is a scope to do the research. And some more, even some, one of our friend is asking these areas, na, till in that areas no one is published with respect to 3D printed concrete microstructure analysis or durability studies and all that. Only basic mechanical properties, all these are only going. So there is a lot of scope for the people, those who are working in this 3D concrete printing area. But you have to go through, thoroughly go through the available literature review, and you should be strong with the soft computing skills, and you should be strong with the preparation of additive. I am giving one example of geopolymer concrete. You can go for with any other concrete also, which is you feel it is locally available and it is going to be. But you see that when I am going to prepare layer by layer, some properties are there actually based on the shear, bending, twisting, then whether any cracks are going to be formed, because you have to give sufficient time to uh, uh, come from the fresh state to hardened state. Na? Before going to the hardened state itself, again we are going to give one more layer. So what will be the bonding between them, how they are going, or is anything required as a bonding agent in the middle of the layers when I am going to give the layers, or even either these fibers may be small micro size fibers may be added in the because workability wise it should be very workable. Otherwise, because it is not manual, na, simply once you are giving the mix additive, simply it will go on working, giving it through the nozzle. So its workability wise, you have to work out the flow properties and all these rheological properties, everything you have to study. So there is a scope going in-depth rheological properties, but there is a scope in-depth durability studies, and there is a scope in-depth microstructure and analysis of this 3D printed concrete. So whoever wants to work, definitely they can go for that. And when it comes to the infrastructure projects, already we have discussed and we have shown two different bridges. And here also I am showing one 3D printed bridges, Striatos Bridge in Venice, Italy, and Phoenix Bridge in Lyon, France. These are the two different bridges what it is prepared by using the 3D printing concrete technology, and with a improved durability and sustainability. Okay, and even you can go for the roads also with a improved durability and sustainability. Even you can go for even water management systems. 3D concrete printing can be used to create complex water management systems such as canals and dams. So in canals, actually, it is going to be the same type of layer with a what I can say, with a trapezoidal shape or rectangular or circular like that, canal is goes for kilometers to kilometer. So you have to prepare prefabricated layers. Then one by one, when you are giving, you have to provide the interlocking. Sometimes no need of steel also, or sometimes we may provide some fiber reinforcement material in that, or even you can have the concept of prefabricated or post tensioning technique or pre-tensioning technique in the preparation of that layers itself, so that it is going to be durable, and the ductility of the it is also going to be improved, and it is going to give the long life actually. So particularly in disaster reliefs, because see, if you go through the disasters actually, in case of disaster, immediate alternative shelter we have to provide to the lakhs of people. Lakhs of peoples are going to have, they are losing their homages, and they are going to be on the road. And that too, at that time, we have to give minimum essential requirements, toilets, or shelters where they can take the temporary accommodation. And all these are prefabricated, whatever showing here 3D printed shelters, they can be moved from one place to another place. Actually, they all these are panels actually. They you can demold them, and again you can mold them in the required places. You can deattach them, or you can attach them whenever it is required. They are going to be interlocking, no need of any external things. Simply you interlock and you prepare that homage and utilize it in the emergency types or in the disaster. Because in case of disaster, this emergency repair and rehabilitations are very much important. And when you come to the this SDG, Sustainable Development Goals, all of you know that 17 goals are there, 17 sustainable goals are there, which are defined by the United Nations. And out of these 3 or 4 goals we can achieve by using this 3D concrete technology. Goals targeting poverty. That means we can remove the poverty, because you are going to give the alternative shelter, and minimum shelter you are going to give to all the people. And by this, even if you start a small scale industry, so that the poverty can be removed. And health and well-being, because these are the health and well-being we can give from this latest 3D concrete technology. So SDG 3 also we are able to achieve. And clean water and sanitation, because once you are going to able to prepare any model, then even you can prepare a temporary tanks and all that. Even sanitary houses also you can prepare by using this 3D concrete printing technology, so that the health and wealth both are going to be good. And particularly the sanitary things, SDG 6 says about the water and sanitary, so that goal also easily we can achieve. And the climatic actions, that also we can take care, because uh, by using the 3D concrete printing, we can go for the. And so here I am coming to the geopolymer concrete and its application as additive in 3D concrete printing. Because uh, basically, I am trying to do the research in this direction. So I started working on geopolymer concrete only with the fly ash first. So obviously, those who are working on geopolymer concrete, if you are using only with the fly ash, definitely for activating the fly ash, actually we need some temperature. Without uh, heat, the fly ash is not going to, even if the sodium hydroxide is there, sodium silicate is there, because without the activation, this geopolymerization is not going to be completed properly, and it is not going to activate that silica, alumina, those are there, they are not reacting with other binders, and you are not going to see the proper geopolymerization. So that's why that technique is there. But afterwards, we have the preheating or post-heating we are doing to activate this. And generally sodium silicate or potassium silicate, sodium hydroxide or potassium hydroxide based one we are going to use in preparing the geopolymer concrete. And yesterday also I told you, better if you go for ash and slag combination, then definitely it is going to be a very good, even at the ambient condition only you are going to achieve. So actually this is the step-by-step procedure. First dissolution will take place, alkaline solution. We are making the dissolution of all the alkaline solution and binder. Then nucleation will create, small nucleation will happen with the silica and alumina. Then oligomerization, that is oligomerization. Poly, that means salate will form. That is called oligomerization. Then polymerization. Finally, this is a polymerization. That's why we are calling geopolymer paste. Finally, from the polymerization technique, we are going to get this geopolymer. And once you are getting this, we are going for curing for certain days. Then you can use it as a geopolymer concrete, and it is layer by layer. So if you see these, all this when you are using a geopolymer concrete, these type of benefits are there. Reuse of industrial waste, because in the preparation, whatever the binders we are using now, they are reuse of industrial waste. Then it is going to be a eco-friendly material, because all what you are using is industrial weights and environmental friendly concept only. No harmful gases are going to be produced in the preparation of this geopolymer concrete, so that it is going to be environmental friendly. And so that's why it can be recommended and sustainable. Already yesterday also we have discussed what is the concept of sustainability. We have to maintain everywhere some sustainability. Then only the future generations will get the benefit of the natural source resources. Otherwise, it will be a very big question. And reduction in CO2 emission. This is very much important. You should have a reduction in the CO2 emission. Otherwise, if the CO2 is greenhouse gas problem will come, then CO2 is there. Now we are facing in Delhi, in all places. Then reduced global warming. If all these are there, reusing, the environmental friendly, sustainability concept, then CO2 emission is reduced, then all this will reduce the global warming. Because of the global warming, all of you know that the earth temperature every year it is increasing. So because of this, actually what happens is the ice or the water is generally, if it is very below 0 degrees, it is in the water ice form. So that water in the sea or in the Atlantic Ocean, in that areas, it is that ice is going to be uh, becoming the water, and that we are slowly this water level in the sea is going to increase suddenly sometimes because of this. So if global warming is coming, it is very dangerous. If the suddenly this all the ice is converting into the water form suddenly, then even you see now in the so much climatic changes we are observing in the world. Even in the Himachal, all these areas, whatever that sudden fall of some rock itself, hill rocks itself, they are moving like a liquid. And if they flow suddenly without giving any warning, so it will be very dangerous and there is no escape to people. So lots of problems we can face because of this. global warming. So we have to avoid that. Okay. So this geopolymer concrete is first Davidovitz, he started in 1978. Actually, he has started working on lime mortar and all that. How these people, why these are more durable after 400 years, 500 years also, single crack is not there, and these are durability wise, these are very strong, but our regular concrete is not going to be that much strong. What is the chemistry behind this? What happening here instead of this hydration process, there the polymerization is takes place. When this alkaline solution is reacting with the binders of silica or alumina content, then there will be a polymerization, and because of this, actually initial days it is started with the small, with the even in the preparation of the bricks of earth bricks and all that. So that's why it is given as a geopolymer, because in case of road works, in case of soil mechanics and road related works, and where the works are related with the soil, generally it is started from there. So, but the name itself, it is giving geopolymer concrete. Okay. And so we have discussed the step by step how it is going to achieve. So additive for concrete, 3D printing geopolymer concrete, already we discussed how to prepare. Even yesterday also I told you, mostly we are using here this sodium hydroxide or potassium hydroxide, and these are, they may be in the alkaline, they may be in the solution type, or you can purchase it pellets or powder. Then you can make the required molarity and required, even when you are preparing the sodium hydroxide, that also, suppose I want 10 molar, already I told you, NaOH means it is 40 grams. So into 10, so 400 grams, and I have to take water. If these two, if I dissolve, then if I am getting a 1 liter of liquid, that is called 10 molar. 400 into 10, 400 grams, 40 into 10. Similarly, when you are going to sodium silicate, 50-50 is also okay, or 48-52 is also okay. Like that also, you can take the dosage of the water when you are preparing the sodium silicate solution. And again, there will be a ratio of sodium hydroxide to sodium silicate. Generally, when you are preparing the concrete, we will take at lower ratios, like because for concrete you should get the good workability, so that the ratio is going to be 1 is to approximately 1 is to 2 or 1 is to 1.8, like that we will use sodium hydroxide, sodium silicate for concrete. But if it is a mortar, or but if it is for a paste, generally the ratio is going to be 1 is to 2.5. Yes. 1 is to 2.5 or 1 is to 3 also you can use. See, there are, hello, hello, any problem? Oh, slides
There
are
are
not
other
connecting.
slides also.
Okay,
Only
okay,
one slide shows.
1 minute,
Hello, sir.
Yeah, I am
Please
sharing.
share other slides.
Now it is sharing. Hello, now slides are
Hello.
sharing. Yes, now slides are sharing. Madam, now you are able to see the slide?
One slide, sir.
No.
Yes, sir. Yes, sir. It's visible.
Visible, na? Slides
Sir.
are visible?
Yes.
Okay, right.
Yes, sir. Yes.
Okay. So basically what I am saying is, if you are preparing a paste, the combination is different. If you are preparing a mortar, the combination is of this is going to be different. And even you have to maintain the alkaline binder to alkaline ratio. That also different, because when it is a mortar, that much of workability problem is not going to be there, then you can go for a higher binder to alkaline ratio. But when it is a concrete, you want more uh, workability wise, it should be very good, because in concrete means again this core set size aggregate is also going to add. So accordingly, you have to take the ratio. Generally, if it is a paste, we can go with a 0.3 to 0.35. But if it is a mortar, if it is a concrete, sorry, paste or mortar, we can go 0.3 to 0.35. But if it is a concrete, that alkaline binder to alkaline ratio, generally we will use 0.4 to 0.45. So these things are slight, it depends upon what type of ash and slag you are using, what type of, even when you are going for the this activators also, you may use sodium hydroxide or sodium silicate, or you use potassium hydroxide or potassium silicate. Even you can prepare them in your laboratory, or ready-madely available solutions also available. Okay. So like that, it depends upon how you are going to prepare the ingredients. Suppose if you want to develop a self-compacting geopolymer also, you can prepare. Accordingly, additional admixtures and viscosity modifying agents are going to be added in that, and accordingly, we are going to prepare the solution. Okay. So basically, why I am giving this much of detailed about this means, because in case of preparation of this 3D printed additive, similarly, if you are not preparing on your own, and if you are not having control on that workability of the layer, then thickness of the layer, even 6 mm to 10 mm only we will add initially. And even without fibers also, when you are going to, when it is coming out from the notch, actually from that tip, it should be just like how our pen is going to flow, like that it is smoothly, it should come, and there should not be any boulders or any size which is greater than the your nozzle size. Otherwise, it will struck up. So all these precautions we have to take, and we have to prepare. So developing geopolymer concrete for 3D printing, here what I can say, key considerations is the mix design. So optimizing the geopolymer concrete mix design for 3D printing, including the type and proportion of aluminosilicate material, alkaline activator and aggregates. That only I am discussing till now. You should be a properly, you have to study all the rheological properties, because with the flowability, viscosity and thixotropy of the geopolymer concrete to ensure optimal printability. So whatever the additive you are preparing, that is the main important ingredient in this 3D concrete printing. So that's why you have to see its flowability, viscosity and thixotropy of the geopolymer concrete. These basic studies, rheological properties, you have to check, and once you have satisfied with the optimal values, then only we have to go for printing. Particularly it comes to the setting time, adjusting the setting time of the geopolymer concrete to allow for sufficient printing time and minimizing delays. What happens is there should be a sufficient setting time. If it sets very quickly, also very difficult. If it sets very late, also it is difficult. So that's why you have to maintain, adjust that setting time based on your based on your ratio, what you are taking from the binder to alkaline solution. From that only you can, you have to do number of trials, which one is going to be suitable for your this, and how you are going to achieve this success in setting time, that you will take care. Okay. Then mechanical properties, ensuring the geopolymer concrete has sufficient strength, durable and tough enough in ensuring it meets the required standards. So that are these things. Then what are the benefits of geopolymer concrete? If you say, already we discussed earlier, it is going to be sustainability. Geopolymer concrete made from industrial waste material, reducing the environmental impact of traditional cement production. That's why we are calling it as a sustainable and high strength. Geopolymer concrete exhibits very high compressive strength and durable. Again, in this, suppose you don't want that much of strength. Let us say it is only a small decorative purpose. It is not a structural element at all. You are preparing it. Even chairs or suppose some in the park we are going to have some benches. Na? This type of things also you can prepare from by using not only all the structural and non-structural elements also, some chairs, some sofa like things, or some sitting tables, or some different or for a flower vase you can make a pot like that. Anything you can prepare here. Suppose if that much of strength is not required, only some different compressive strength, all this only required for you, not with respect to other parameters, then this sodium silicate to sodium hydroxide ratio, whatever I am saying now, these are the regular for concrete purpose. I have told you for structural elements, for modeling and that. If it is not a structural element, it is a non-structural element. Actually, you can reduce a very that sodium hydroxide content. You can reduce. We can use only sodium silicate only, because our sodium hydroxide, because in presence of fly ash and GGBS, where there is going to be have a more silica content, like instead of slag you can use a rice gas also, where the silica content is more. If you are using a binder where the silica content is very high, in that cases even you can reduce the ratios of sodium hydroxide or sodium silicate only by using the sodium hydroxide itself, or only using the sodium silicate itself. You can prepare, but sometimes with a little amount of soda, like 1:7, 1:6, like that also we can go with the sodium hydroxide and sodium silicate. If you are not expecting a very high strength, a simple strength it is required with the combination of fly ash and GGBS, then we can go for a one type of this alkali activator also you can use. It depends upon the what type of application you are going to do. If it is a simple application, even we are doing the research with respect to a single activator also, you can go for doing it. And nowadays, if you see, this sodium silicate is available like a byproduct. Instead of going to purchase it, and or instead of going to prepare it from yourself, even you can go for from some industries, this sodium silicate is coming as a waste. So you take that and you can use it here now, then it is going to be very economical. High strength, already we told, low carbon printing, all these things we have discussed already. And challenges and limitations. So challenges already I told you, because here when you are using, suppose you take a regular cement based or aggregate based one, when you are having the dry mix, wet mix, and pumping it through these, there are so many challenges ensuring strength, durability, and sustainability. And not only that, navigating building codes and standards,
Excuse me, sir.
then scaling. Yes.
Slides are not changing, sir.
Hello.
Slides are not changing, sir.
Slides are not changing. Now,
Yes. When I are being changing, that's changing. But till now, the same slide it was there.
which slide was there till now? I can come back again. You have seen all these slides.
Yes. Yes.
This is
Then
okay, na?
again.
This
Ah,
one.
no, disaster that is not there actually. One
Okay.
slide back, sir.
This one. Disaster one.
Yes. It's not
Will-
actually changing as you go on. It's not changing actually.
Okay. Now I am keeping like this only, and I am changing. Now it is changing, na?
Yes, sir. Now it is
Okay.
changing.
So I am not going to the presentation mode. Simply I am keeping like this. You can see both this numbering of slides and this main slide also. No problem. I will keep like this. So whatever it is missed, once again I will discuss. These are the sustainability goals we have discussed, and these are the step-by-step preparation of the geopolymer concrete, what we have discussed here. And these are the additives, how to prepare the geopolymer concrete. And this is the total how to prepare a activator and how to utilize this activator, combining this activator with the binders, then preparing this, then what are the materials we are going to use for the
We have already
geopolymer
discussed
concrete.
these things, but these were not changing actually. So we thought that you are saying this by without looking at the slide
Oh,
only.
ho, ho. Earlier they have not changed, na? Oh, ho.
Yeah,
You
yes,
are thinking that just I am discussing.
yes, sir.
No, no. For each slide, have the slide based on that only I discussed actually. Okay, okay, no problem. Now you are able to see these slides, na?
Yes, sir. Yes, sir. Now it is.
Okay, okay, no problem. That's why. If you want again, I will go to the back also.
No, sir.
All the
Not not
slides.
necessary. Not
Just
necessary. Sir.
just once I am going to show all the slides. If anyone is missing, just you go through it. And now we are discussing here. So we are preparing, we are using all these type of materials. And what already I told you now, here three things are there. Whether it is a paste or it is a mortar or it is a concrete. Sometimes for some preparations, very small thickness layers or just for a decorative purpose, if you are preparing, only paste also can be used as a additive. Or sometimes we need some fine aggregate also, then it is called as the mortar. When it is binder is mixed with the this fine aggregate is also used, then it will be a mortar. But the ratios are going to be goes on changing when you are saying it is a paste, when you are saying it is a, because when it comes to the flow studies, for paste, the flow properties are going to be different. For a mortar, flow properties, flow test is also different. For a concrete, this rheological or workability properties are going to be different actually. Okay, accordingly. And these are the mixed proportion and rheological properties, setting time and mechanical strength. All these things we have discussed here actually, right? Then process of concrete for 3D printing, material selection, that only we are discussing actually. Selecting suitable aluminosilicate material, alkaline activator and aggregate for geopolymer concrete. That is only I am saying. Based on your type of requirement, whether it is a decorative purpose or it is some model or it is a concrete element or it is a non-structural element. Again, in concrete also, two things are there. It is a non-structural element or a structural element. How you are going to utilize is based on that, the limitations and uh, preparation, some slight changes are going to be there. Mixed design optimization, that is also we have discussed. Rheological characterization, that only I am saying. Printing trials. So you have to do so many trials to evaluate the printability and performance of the geopolymer concrete. In single trial, you may not come because that flow and that the connectivity, once you started making this printing, it should continuously, it should come. There should not be any gaps in that. Like that, all these minimum precautions we have to take actually. This is also benefits of geopolymer concrete also we have seen. Lower carbon footprint because CO2 emission is very less, high strength and sustainable. Because of that we can say, and these are the challenges and limitations also we are going to say, because it is finally connected pumping printing phase. It is connected to this nozzle and from there only you are going to do, and even if you are preparing in the laboratory style, no need of this automation, no need of robotics. Simply manually also you can make the layers just for a trial purpose. And after that you can go for the robotics. So future prospects. See here, when I am saying a future prospect, here you can see that how this 3D concrete printed, whatever the shape you want in that shape with a all this, if you see, it is just like a mesh. Even a human being face also you can create by using this latest technology. And even if you want to prepare it like a mesh, not a complete solid, then also it is possible. All these combinations depends upon what is the nozzle type it is, and how uh, pro, how much confidence or how much control is there in preparing this robotics technology and how you are going to handle this, how much programming you are doing, because this is all this robotics part one, this is coming to the this uh, notch and all that. Here we are going to connect this, we are going to give this additive from this notch only, and we are going to keep it. Widespread use, see, increased application. 3D concrete printing is expected to become more widespread in the construction industry with increased adoption in residential, commercial, and infrastructure. Even large scale also you can do. So it is in the research now, but surely within in 5 years, I can say it is going to come in the application state also. Even this 3D printing technology, once you adopt with the, because here, obviously to operate the all these, we need some power system and all that. Na? That also you connect with the solar, then again it will become a new project. See, for operating this robotics and all that, we need power. That may be AC power or DC power. Instead of that, you have a uh, you can see the you can connect this with the alternative sources, like how to use a solar system in this technology to operate this robotics. I can use that solar panels, or I can use that solar technology. Like that, you have to combine with the different things so that you will get the advancement of this. See, now this advancement in technology, you see how different layers and how difficult. If you want to develop this such type of structure manually, it is impossible. But this is possible only with the help of 3D printing. This much of complex structures or this much of complex models also you can prepare with the improved sprint speed, enhanced mechanical properties, and other technologies. You can combined by using that, you can go for printing this. So this sustainable and environmental benefits already we have discussed why this is going to be very much useful. But once what I am going to say is the additive in initial stage, suppose you are not able to prepare the additive, just you go for a even ready-made available additives also available. You can purchase it. You can start with that. Otherwise, you start with the regular cement mortar itself. No need to go for geopolymer and all that. First to get the a control on the layered concept, then a control on the studies on the layered concept. Then you can go for any new applications. See here, these are all the foundations actually, or a support. Over this, I can put a steel column, or suppose if your electrical poles are there in the street, I want to give the support. Simply, you prefabricate these foundations like this and you keep them in the ground. Then from there, you give the pole connection like that also. See here, one bench actually, it is in the park. How nicely it is prepared by using the 3D printing technology. And it is used, it is kept in the park. So that innovative things you can do by using this 3D concrete printing. So like that, it depends upon what type of material you are using here. Okay. So special features of the system including the following. Design freedom. So this is the best advantage of this technology. Design freedom will be there. Construction efficiency is going to be very high when compared to the regular concrete. And automation, obviously, let us say you have prepared one model and you want that same 100 numbers. Automation, because it is automation, within fraction of seconds, if you give the command and your additive is ready, you should be ready with that. But for it, just it is just like a taking a Xerox like that only. Making a duplicate copy is very simple for it. First, once you are able to satisfied with the main model, then automatically getting the automated numbers by using the robotics is very easy. And labor safety, because here everything is under controlled manner only you are going to do. Obviously, there will be labor safety and even very less number of labor only required, and no need of any farm work, because after layer by layer we are doing, so that there is no need of any farm work, and simply you can go for constructing it. Okay, so this is the overall idea about the 3D concrete printing. Frankly speaking, I am also working on this, and two research scholars are working on this 3D concrete printing, and we are developing the laboratory model also, and we have developed a small that setup, laboratory setup, 1 meter by 1 meter one and 2 meter by 2 meter one we have developed. And in manually, initially we have done manual layers. Now we are trying to do replace that manual with the robotics. Simple. We are connecting to a system, and through this system, this first we are trying to move it in regular shape only, just horizontal, vertical, and in all the three directions: X direction, Y direction, and Z direction. We are trying to move it. Trying to move it for the regular shape only now, regular rectangular or square shape only. Once we are succeeded in that, again we are going for the different curved shapes and all that. So slowly you have to improve your technology, and you will be in succeeded. Okay. So this is what any more questions it is the given here. Please mark the attendance. Okay. Then slides are not in presentation mode. Actually, I have not keep in presentation mode, because if I am keeping in the presentation mode, I don't know these slides are not changing. Okay. So because of that reason, I have kept, I am not keeping in the presentation mode. That is only the reason.
Sir, one question, sir.
Yeah, please.
Sir, actually, in the 3D concrete printing, the procedure is actually to cast the elements layer by layer, isn't right, sir?
Yes,
So,
it is layer by layer, yes.
layer by layer. So, my question is that in reinforced concrete structure, where we want to construct the beams, columns, and slabs, first shuttering, then after caging, reinforcement caging. So, once caging is there for columns and beams, so how the process can you make us visualize, sir? Means how the process will be as it is layer by layer. So if our column caging is there and beam caging is there, so how to place the concrete layer by layer if a column is going to extrude here?
Casing means you are saying in regular, that is I told you, no shuttering is required here.
Okay.
You are
So
saying about that shuttering, na? See, if you are preparing a
not
column,
about
first
shuttering,
you are
about
providing.
reinforcement. Reinforcement cages. So while we put the reinforcement beams for columns and slabs, etc., and as we are going by layer, so how to accomplish the job?
In the vertical direction, you are asking this reinforcement, or in the horizontal direction?
Both, sir,
Vertical.
both in the horizontal direction also and both vertical
In
direction
the
also.
horizontal direction, let us say you have given some layer. So in these layers only, suppose generally in the horizontal direction, what we will do, we will give the reinforcement only, arrest the cracks. If at 4 feet height, then we will go for some reinforcement. Then we will give in case of load bearing walls, I am saying.
Okay,
That's
no,
why
it's for columns and RCC columns and
here
the
no
structural
concept of.
elements.
Here, no concept of separate framed structure, then partition like that. It is now, have you heard this foam system type? Like framed structures nowadays we are using now. See, they are going to, suppose if I want to construct one 2 BHK house, first they are preparing complete farm work. Then only
Correct.
they are filling with the required material. Like this concept it is. It is not like your regular, first you go for a column, beam, frame, then you will go for partition. It is not like that. It is the concept of the, it is like just like a load bearing wall, I think. There is no concept of separate framed structure, then structural elements, non-structural elements, like that we will do now in regular case. You are saying first
Right,
you
sir.
go for foundation, then you will go for the plinth beam, then you go for the columns, then you will go for the beams. that concept will not come here. Here entirely it is just like your load bearing concept type.
That means,
Entire
sir, actually we should use this techniques without reinforcement.
with reinforcement also you can use, but here one layer is there, another layer is, you are going to give layers side by side na, in the middle that reinforcement will come if it is required.
Okay, so for all the heavily reinforced structures, as I told you, tall building and bridges, whatever it is, we are first doing the not first. If you do the layer by layer concreting, so in between we have to put the layer, cages, reinforcement cages, isn't it, sir?
Yes, if required, tension is also required in your structure. Actually, till now what they are doing is better. What they are doing is the molds what they are preparing is either it is pre-tensioned or post-tensioning. Till now, it is like that
Okay.
only.
So whatever
Prefabricated.
the figure that you've shown in IIT Madras, one building and
Huh,
another post office building, have they used the reinforcement within that?
inside reinforcement is there, that is prefabricated in the lab. Means in a controlled manner, they prepared this. You have seen two, for the portico, you have seen the columns and all that. Na? In that reinforcement is there, but that casing, for that a separate system they developed for preparing this column with the reinforcement. Like that, they separately prepared and then they kept there like that. I can say till now it is prefabricated stage only.
Okay, but for
In
the
the because
commercial buildings nowadays,
uh,
with the along with reinforcement cages, I think I am not able to visualize how to print the
yes,
concrete structures with the
because in India
reinforcement.
actually very slowly we are doing this work with reinforcement also it is coming. Actually, it is in the everything is in the research stage only. Frankly speaking, confirmed even code is also not available. Exactly, you have to follow this method like that. But you understand, na? Generally, this post office and this single, if you see the post office, no columns are shown there. It is
Yes, sir.
only a round structure. Completely, it is layered concept only. But when
That
you
means
come to
in that particular structure, we do not have any reinforcement, isn't it, sir?
yes, reinforcement, it is not there means wherever it is required only in the slight reinforcement, like very small amount of reinforcement only in the layers as a horizontal bar, they may be given. I do not have idea, but they may be given
Yes.
in the layers itself. But in the
That's
vertical direction, I think no need of anywhere because here that is load bearing structure only, na? It is only a single floor. No more floors are
for
there.
bending elements like the beams
Ah.
and columns for like rise structures or two-story structure, three-story, whatever it is, but we need badly the reinforcement to take the bending stresses and all. So
Slowly, that technique also will come. Slowly, even prefabricating the structural elements or directly preparing with the reinforcement, it will come because see now everything it should go through the that nozzle only, na. So
right,
when I
sir.
am saying a reinforced cement concrete, again the size, the mortar, the concrete ingredients are going to be different actually in regular time. So when you go to the framed structure, the concrete, when you are going to prepare it, the quality and you maintain that minimum strength, that is going to be different. Na? So that's why no one is going for a high-rise buildings and all that. Simply load-bearing framed structures only. Till now in India, in other countries, even so many other videos are there, but we don't know how much possibility there is to do. Till now, it is in the research actually.
Okay, sir.
Everything is in the research. Even if you try, you can try as a structural element separately. But the thing is, it should be developed in the controlled manner only. Okay. I think next session is going to start, I hope.
I have
So,
question, please. Good evening, sir. I have one question.
Okay, thank you, sir. Thank you so much.
yeah, yeah. If
Can
even any doubts are there, you be in contact with my mail ID so that we will definitely I will share whatever the papers I am publishing
Thank you
related to
so much.
this. And
Thank you so
what?
much, sir. Thank you so much.
Right.
Very
Thank
nice.
you.
One short question, sir, please.
Right. Thank you.
Thank you,
So,
sir.
yes, Pankaj sir. Yes, thank
Thank
you.
you, sir, for your nice presentation. And
Right.
if any participant has any doubt, then they can email to our sir, and
Yes.
they can rectify, or they can have an interaction with our sir. Thank you, sir, for your nice presentation once again.
Yes, thank you, sir. So I am going to out from this, and I think next speaker is ready. Okay. Thank you, sir.
Thank you, sir.
Thank you very much.